Welcome to Homework Lib.
So over here we're going to have the following compound with unknown chemical formula. As a solid, we know that we have a mass of this compound of 0.796 grams, and after the decomposition of this compound, we measure that the amount of copper as a solid is equal to 0.387 grams of copper. We want to determine the number of moles of chlorine in the original compound. So in order to do this, let's remember that whenever we do the decomposition of this compound, this is going to produce X moles of copper plus Y over 2 moles of Cl2 as a gas. Correct? So if we know the amount of copper that we had initially in the amount of moles, we are going to be able to determine the value for Y. In this case, from here we know that the mass of copper divided by the molecular weight of copper is going to give us the amount of mole of copper that we had. This is going to be 0.387 grams divided by the molecular mass, that is 63.55 grams per mole. This will be 6.09 times 10 to the minus 3 mole. And now the rest of the mass is going to correspond to chlorine atoms. So mass of chlorine is going to be equal to mass of the unknown compound minus mass of copper. This is going to be 0.409 grams. Now, to get the amount of mole of chlorine that we're going to generate of Cl, and of Cl is going to be equal to 0.409 grams divided by the molar mass of chlorine, which is 35.45 grams per mole. This is going to give us 0.01153 0.01153 moles of chlorine atoms. Now, just to be more accurate, let's keep more decimal points over here. This will be 6.0897 times 10 to the minus 3 mole and 0.1153 mole. So what we can do is divide the amount of mole that we have of chlorine divided by the amount of mole of copper to know how much we're going to have of each of them. This is the same as the ratio of Y divided by X. So after doing this division, we're going to get over here 0.01153 mole divided by 6.0897 times 10 to the minus 3 mole. This is going to give us 1.9. So the ratio is going to be almost equal to 2. So one of the possible formulas would be, approximating this as 2, would be Y is equal to 2 times X. So we can say one of the potential results could be copper Cl2, which is going to be consistent with the known values for the balances of copper and chlorine. This would be copper chloride 2, right? Now, just to verify if this answer is correct, we know that this compound is going to have a molar mass of 134.5 grams per mole. So, according to our equation, this would produce copper plus Cl2, right, as a gas. It's a solid after decomposition. So, the initial amount, which was 0.796 grams of the compound, if we divide it, this would be amount of mole of Cl2, if we divide it by this molar mass, should give us a value quite similar to the amount of mole of copper, which in this case gives us 5.9 times 10 to the minus 3 mole. Over here, we're asked to only keep 3 decimal places, so this would be approximately equal to 0.006 mole. And if we round up the result that we got over here, this would be the same thing, 0.006 mole, just to keep 3 decimal places. So that means that the molecular formula is copper Cl2. Oops, Cl2. With that, it would be all. Thank you very much, and have a good one. Oh, just for sake of reference, this would be the number of mole of chlorine that we had in our initial compound, and that would be all. Thank you very much, and have a good one.